All right. Welcome back. Yeah, so we were building the animation editor, and I've gotten a bit of progress off stream as well. So right now I've actually implemented. So let's see what we did last time. So last time we got sort of done the sort of generic layout thing with all the UI and handling inputs and stuff for the editor. And we started working on the actual interface. So yeah, we got all these things done. Basically the setting texture for the animation, adding new animations, listing animations, the animation detail. When you select an animation, you can change the name, set the grid size, frame duration. You can see total animation duration. You can delete the animation. Yeah, and the frames. So now we can see the frames, and I made it so that you can see them as an image. So you can see them visually now. And then we also have the... Although there's one more thing that we need to do. We need to account for the origin, which I haven't done. So I need to add that as a little to do there. Okay, and then we have adding frames, replacing frame with another graphic or sprite. We have the highlight on the hover grid cell. I did add frame details as well, so now we have origin, we have duration scale, we have yeah, you can see when the frame is starting, and also delete a frame. So that all works. I also made the preview window with the animation running, so you can see the animation. So the only thing left here is basically the reload texture button. I'm not gonna do this one for now, which is, it's not really that important. And this one is well, we need to do it in order to see the preview and the frames accurately. But yeah, we got almost everything in here. But there's one more issue, which is I'm gonna try and match the serialized JSON data with old format. So what happened is that in the old animation struct, we had a specialized or like a serialized version of the animation struct, which made all the array lists into slices, which made it, when you serialize the JSON, yeah, it made it look good. But if you try to serialize an array list, it's gonna have items and capacity in it, which doesn't match with this old format, which doesn't have that. So I have been figuring out a little bit how to handle that. So I tried to make a generic sort of JSON serializer and parser for an object, but it turned out to be a bit more of a hassle than I anticipated first. So I mean, what you could do is go ahead and go into all of the objects that have array lists in them, put a custom JSON parser and JSON serializer in them, and then use that. So we could do that, and I have actually made sort of a helper function to actually do that very easily. But then it's also a little bit invasive, I guess. I did try to figure out another way. I forgot what I was doing now, but if we go and maybe we can look at and see. Wait, where's... Wait, what's happened? Find. No, this is not. It's some. Oh, I got the caps lock on. Okay. Okay. I was like, what happens with my key bindings, or yeah. So I want to do this, and yeah, what was I doing? So I made this helper, but I started making this helper file for JSON serialization. So we do have a way to sort of write a generic value. Now we have a way to sort of stringify a generic value, and it takes into account if you're looking at an array list. So it tries to detect if we're looking at an array list. So what it does is it's basically looking at a type, checking if it has a declaration of items or a field of items or called items, and checking the type of that field if it matches sort of a slice type, and then it returns true for that. So then we can write this as an array list. I realize if you have another struct that has items that is actually a slice, it will also serialize into an array. So it's a little bit of a caveat there, but I'm just gonna have to make sure that we don't have that. And it's gonna be pretty obvious in the resulting JSON as well. But yeah, so it's gonna detect if we are trying to stringify an array list, then we just print out the array directly, and none of this items or capacity is gonna be there. It's just the array. Otherwise, if you have a struct, we also have a special case for that, because we want to loop through all the fields and run this function recursively again on those, so that if you're looking at a struct, every field will sort of also be handled by this stringify. So that works very well with this sort of stringify operation. But then you go to the parsing operation, and it's a little bit different. I haven't actually completed this because it was a bit of a hassle. So because yeah, I was just thinking, so I mean, technically if you have a list of objects here, this won't like write it. This only writes the items like this, right? So we should really, actually, this is not even, if we have let's say we have this is a list of objects that also has a list, an array list, then this doesn't work. It's gonna just work on the first level, so to speak, like on the first object, but then any child fields of that object will not actually work with that if you have an array list with objects in it that has an array list. So what we need to do then is, well, one thing that we could do, as I said, we could use this function for all of the structs that are supposed to be serialized, which are the persistent data document things. So it's not like all structs. We only use it for some of the structs. But we can put JSON stringify using this function. So it's gonna be pretty simple to we just have to call this function with self in object and JW. So, and that you will get a good stringify of that. But you have to put that on all of the structs excuse me, that has a field with an array list in it. And also if that array list has any objects, or like, yeah, it's going to be all the structs that has array list on it. So but then for parsing, I'm doing this. So parsing an array list, we're taking the type that we're supposed to parse, which is an array list. And then I have this convenience function called element of. There's probably maybe there is a standard. Yeah, okay, so there is this one. So you could use this one, I guess, instead. I guess there was, yeah. So let's actually use that instead, because it's better to use built-in stuff. Okay, that does the same thing. So this one basically does the same thing, although it, oh wait, it actually looks for items as well. Well, I guess here we could use it. So here we can, so this is actually element of array list. Let's actually do this. So, and then we return does this have like a fail safe, or it just becomes an error or something? Yeah, if it doesn't fit, it becomes an error. So that's why I don't really like, I want this, but it's like a version where, yeah, like I'm doing here, I return null if it's not actually an array list. And but this function doesn't do that. It just fails. It compiles a compiler error. So it's like you have to check first if it's actually one of these cases, and if it's not, then you don't call this function, but if it is, then you call this function. So I don't really like that. It's like I want to call this, yeah, and then get a maybe out of it. So so yeah, but anyway, so we know that it's an array list. It's gonna have the pointer type. So we are actually just interested in this. So let's actually just use this and go back to, yeah, I'll go back to using the thing that we had here, but I wanna rename it to array list. So it's array list specific. Okay. And then what we do is, this is what we wanna return here. It's the we wanna return, well actually we wanna return a slice of this. So it's gonna be a slice of the element. And we're just using the standard inner parse for this array, because we know we're getting an array that we need to parse. So we're gonna parse it into a slice of the child element. And that's basically it that you need to do for that. Now, I'm not gonna probably, because the problem here when you try to parse an object, then you have to do the same thing. Like you have to go through all the, you have to like parse, like you cannot just parse an object or a struct. Okay, I just have to take a little bit of a break here. BRB. I'll probably have to take a break here soon, but yeah, as I was saying, so yeah, I think the issue here is you have to sort of recursively do this and sort of go through each. You have to parse the object manually and go through each field and, you know, recursively call these functions. So it's not that great. It's sort of like re-implementing the parsing functions of the JSON library. So I don't really like that. Another thing that I thought of doing was creating. Okay, I removed it here, but I was like, if you create a like, let's say you have a serialized wrapper. And you create well, this is a function, so it takes the input value and returns a struct that is sort of a serializable version. That was my idea. I haven't really, but this is also gonna be pretty daunting task, because you're gonna have to go through all of the different types that it could be, and you have to maintain it if SIG sort of changes the types and stuff. So the idea is you have the value here, and I guess it could be a pointer as well, so you have like a value to a pointer, and then you would have the implementations of JSON parse and JSON let's see, JSON parse and JSON. Wait. No. That's not what I was thinking at all, actually. Yeah, that was my first thing. No, I was thinking of another thing. The idea here is that you would actually go through. Yeah, you would switch on type info of T, and here you would get like all different kinds of things. So you would get like a struct, and if it's a struct, then you have, well, I'm not getting things here, like fields, for example. So you could go through fields and stuff. Right. So, okay. So the idea is that you construct a new type, which is basically a copy of the old type, but with some of the things replaced. So, for example, for the struct, you would go through each of the fields. So you would construct a new struct type. So this would be like the serialized, like wrapped struct, and then this would be a, you know, a type. I think you could use this, which, wait, yeah, I think you can do this. Wait, could you do this? Could you say var, and then this is equal to type info of, or you can just say s. So now we basically copy that, and then I want to say that the fields is equal to something else. So I want to say the fields is, well, what I want to do is I want to for on fields, and we get the field out, and then I guess we could have index as well, because now we can say wrapped struct index. So now we can actually call this wrapper function on this field as well. So we can call serialized wrapper on the field, well, which is actually going to be si, but I want to say that the fields of, well, it's not si, it's s.fields I. Okay, there we go. So I want to set the, I want to sort of transform the fields of this wrapped struct into a wrapped version of the field. Okay, and then in the end we want to return this wrapped struct, but actually we want to make a type from that. So we're constructing a new type here basically. Okay, so that was the idea. And then for all other sort of types, well, you have to go through like pointers, for example. If it's a pointer to one item, then we wanna also go through that pointer. So for example, if you have a pointer here, and we have to switch on pointer.size. So if it's let's say it's 1, then it's just a pointer to another thing. So we just want to return a pointer to serialized wrapper of the child type. Okay, so that's one case done. But then there's like, you have many, you have slice, so you would have to implement this for each and everything. So this function will be called recursively on everything inside this type, and in the end you would end up with a serializable version of the thing that you had. So you don't have to worry about how the struct looks like from the beginning. You can pass it through here to get a type that is serializable and deserializable. Well, I haven't figured out the deserialized part. I haven't thought of that, but this is at least you can start here and try to make it work, because then you don't have to like, this is one way of solving the issue once and for all. But then you would also have to sort of maintain this. I know that in next version all of these are going to be lowercase, for example, but so yeah, so you would have to maintain this through Zig versions. But anyway, that's one way of doing it. Another way of doing it, since it's only the array lists that are the problem here, I've talked about this before, but I have this thing called JSON array list, which is sort of a copy of the normal array list, like this unmanaged array list. It actually has an array list in it, and then it has some, like, just some of the functions. Well, I think you would have to like yeah, you would have to sort of keep to this pattern, like you would have to access the array list instead of just accessing items. So you'd have to say array list dot items instead of just dot items if you're gonna use this. But the thing with this one is that it's actually serializable in a nice way. So we could use this one. We could replace all the places where we use array list with the JSON array list, which makes it all nice and serializable. So I think that's what I want to go with. And there are some convenience function, for example, here with the slice that you get items here, and you can add more convenience function. You could sort of mimic this whole thing if you want, which probably is a good idea, but I haven't done that yet. But yeah, so that is one way of actually doing that. So okay, yeah, so that would have to be like here, for example, in animation I have array list. Now I have to replace it with JSON array list instead. And so JSON array list, do we have it here? Okay, I'm gonna do this. I'm gonna say const JSON array list equals to import. There we go. So now we can import that there as well. Let's remove it. So if I can complete this, this would be really nice to and if it would work. So you would questions like answer or have a question here. Okay, why would this work better? Because well, what we have to do is here we have to say if is array list, and the type is going to be t, because that's the input type here. And then wait, why is this not formatted? It is a function. Okay, it's usually like yellow or something. Okay, whatever. So if it's an array list, then we wanna handle it separately. So we wanna return just the actual items. So we just wanna say, I think you have a nice thing here. This is gonna be, well, actually we can just return element of array list, and then this is the element, and then we return a slice. So we return this type basically. Okay, so yeah, so that's how you would sort of handle that case. So if we are dealing with an array list, we don't just want this to return the basic struct that we have. We want to return this array, because then when you pass this type into JSON, the standard JSON library and the JSON stringify function, it will see an array and not a struct that has items and capacity. So it sees an array, it will stringify to an array, it will parse it from an array as well, and then well, then comes the step of actually taking the resulting object and parsing it back to an array list. So yeah, that's the thing. We could change the clone stuff. We could actually change the clone function for each of the persistent data to be like, if we go to animation here and there's a clone function. So this clone function, we could actually make it so that the oh yeah, the self is not animation, but it is the serialized version of animation. And so then you could use the serialized version frames here. So that would become this in that case. So that's how you could use this to parse from the serialized type. But yeah, it's a bit of a hassle to actually implement this. I mean, it's just it's just tedious just going through all the types and handling them separately. You know, you have unions, you have to go through each of the unions fields. You have enums. Well, enums are just gonna be straight off there, but pointers, you have like basically everything that could have children, like child types, you would have to handle here. But yeah, let's just try and do this, because I'm curious. Here we have many, so the type is actually, it's basically just this. You have a pointer to many, isn't it? This then. Or in theory you could also, because we have stuff like alignment, sentinel, like I don't think if you have pointed to 1 it's gonna have a sentinel. That's not gonna have a sentinel. I don't think that's how it works. But then you have all these other different things. So what we could do is we could just say the wrapped version is going to be p, and then we return the wrapped version here. And then we do the same thing as we do with the struct up there. We just modify the child type, actually. So we just have to modify the child type and say that this is now a serialized wrapper around the child type. Yeah. I think basically that's all you have to do, right? What if we say it doesn't really matter what kind of pointer is, we're just interested in the child type. So actually I think we could just do this. I mean, of course, if this works, I'm just gonna delete this thing here. Okay, now we are getting some. Okay, I'm gonna delete this one as well. Unused capture, so we actually don't need this thing. So let's just do .length instead. Okay. There still could be like compilation errors in here, but should we do this instead? Because it's gonna be like we're gonna have to handle, like it's gonna be just so many places where you have to change things because we change it to JSON array list. It's just a wrapper, and it's gonna just pollute the code basically. So I don't like that actually thing. I'm gonna try this version here, so we'll see if this will pan out. So we have a struct, we have a pointer. What else could we have here? Now I don't understand. Okay, let's do type info. Let's do this because this might work better. So if you do it to a thing first and then it should understand what's happening. Yeah, now we get some completions here. Okay, cool. Right. So yeah. What else do we have? We have frame. I'm not sure what these are. I'm just anything that I don't really understand, I'm just gonna put off. So array is gonna be probably just, yeah, we need to serialize the children. So we do the same thing for pointer and array, I think. Right? So we actually could put these into an inline like this. So we treat them the same. Okay, what else do we have? So we have these three. The type, a type we don't need to do anything with. Bool we don't need to do. It's just gonna be anything that can have like children in it. I don't think enum has, like, because enum has like a restriction on the types it can have, I think. So it's not gonna be that. Enum literal. Okay, probably not anything. We don't need to worry about error unions, errors, floats, functions. We're not gonna serialize a function, so we don't really care about that. Frame, I don't know what the frame is. Like, I've seen this in the type system here, but I have no idea what it is. Frame, function, okay. I'm not gonna worry about that. Okay, comp time float, float function in this in no return, null, opaque. Optional. So optional actually, I think. Yeah, I'm just gonna do it here. Optional. That should also be part of that family. Anything that has child, basically. And then we have undefined Yeah, vector also over here. And let's also, so union is the last thing. So I'm just gonna see, wait. Yeah, okay, so this one has fields. I don't think we care about declarations because that's not gonna be serialized anyway. So yeah, union also needs to be sort of like a struct actually. So I think we can inline as well union and struct. Okay, and if we have anything else, let's do, I guess, inline else. We just return that, I think. Okay, let's start here and we'll see what happens. I think also we need to like type these things. Yeah. Wait, but this is a field. This one is set to, this should be a field, right? So it's actually, oh yeah, we have alignment as well. So I think this actually has to be, the type has to be set to the type of this field. And then you have like other things like the alignment. I think this might have to change. Align of, okay, I will create this field first. And then I will put that in there. Is there anything else we need to? Name default value is probably not gonna be different. Not for array lists anyways. There's not really a good way of doing it, so we have to just take the hit there. Okay, so that should be a good thing to do. Okay. Oh yeah, we have the array list here. One important thing here is also we need to serialize this one as well. Yeah. Okay. Because otherwise the children here won't get serialized. Or, I mean, wrapped. And I think that's it, actually. So let's actually try and implement this now. I don't want to change this into a JSON array list. Okay. So this guy, I've done some experiments here. This one, now we want to go to JSON. Let's make this public. And I did make this sort of weird wrapper here as well. I'm gonna just delete this because it's not gonna work for us. Not recursively anyways. Wait. Yeah. This is not gonna work. So let's remove all that. Okay. So first we want to make the serialized type. And wait, I just realized something. This won't work. Because it's not gonna match the type that we put in. Right. But we okay. Well, actually, wait a minute. Couldn't we implement JSON parse? Oh no, you can't. Okay. What I was thinking is to implement for the serialized wrapper the serialized wrapper type to implement functions, but you cannot actually do that in SIG. You can't have a dynamic sort of constructed type like this and add, let's say we wanted to add a declaration, because that's what a function is. You can't do that. It's gonna ignore this, and I've read from the sort of discussions about this that it's probably not gonna be, you're probably not gonna be able to define functions like this. So what I wanted to do was, let's say I add a declaration, and then you would have to do something like this, and in here you would have sort of a declaration or whatever, and then you would, let's say it's a function, I don't know, and then it would have to be, well, you can't really, I don't think you can't define a function here, but you can do sort of this. You can do a struct, and then define a function here, and then this would be like JSON stringify, and you would define the functions like this, and then you could say JSON stringify here. So that would make a new function like this. But the thing is, you cannot actually do this. So this is not something that SIG supports. So we can't go this route. But then if we had that, then we could, unless we do another wrapper type, maybe. Wait. Could we do that? This is only going to be for structs. All the things in here that are actually, well, yeah, it's only going to be for structs, because arrays and pointers don't have functions. It's only going to be for structs. So technically we could wrap this in another thing. We could do, I mean, I'm just going to play around with this. So let's say serialize wrapper for for lack of a better word here. Let's just try this. So we'll return a struct, and we're gonna have the wrapper, the inner wrapper, which is a serialized wrapper of T. Okay, that's the wait. Yeah, okay, let's start here. And then we'll make a JSON stringify. Actually, you know what? We'll have a value which is actually T, though, isn't it? Because we don't have the serialized value yet. Okay, I have a feeling that this is not gonna go down the way I think, but I'm just gonna wing it here. So here we have self. It's gonna be serialized wrapper T, or this, and then JW and the type error void. So when we stringify, we are actually we want to stringify this thing. But we need the value of that thing as well. So we need to somehow turn the original thing also into this type. So we need a serialize function which will return this. And actually this has to be, I'm gonna call this like recursively. So this is just gonna take any kind of value, I guess. Or do we have to put, yeah, I think we, let's do this. Serialized value, this is the value that we get in. We're gonna return this. So this doesn't need to be part of that. We're just gonna do this. Okay. So we're gonna wrap the thing. Now we're gonna do the same thing we're doing here, except now it's like concrete values instead of types. So we're looking at the type info. If we have a, and technically you don't actually have to pass in S here separately. You can actually pass in this like this, and then you could say type of value, and then value type is, and then I guess we can say S is equal to type of value here, and then we can use that, or we can say T, I guess is more conventional. So right. So now we have basically the same thing here. I'm not gonna look at the errors yet. If we have a struct or union, so how are we gonna do this? Yeah, we want to check, are we looking at an array list? I don't think we need to do anything of this sort here. So if we are an array list, we want to serialize that it's gonna be just the slice, but then we actually want to wrap the children as well. So we actually need to allocate, or do we? Maybe not. Well, it's gonna be a different type. Because we're not gonna, yeah. It's gonna have to be we're gonna have to allocate here. So we need actually an allocator as well. Okay. Because, well, I want to do, first we're gonna create the slice. So this is gonna be the slice where we wanna put the stuff in. And this is gonna be allocator, allocate. And the type is gonna be this. We're just going to return the slice. We're going to allocate a child type, and the length is value items dot length. And we're gonna populate this with a call to serialize. So this is gonna be slice I equals to serialize allocator, also catch unreachable. Allocator with item. So that way now it's recursively applied. And then we just return this slice. So in case of an array list, we turn it into a slice. Okay. Which should be the result of this return type. So it should all work out. We might have to do some comp time shenanigans in here because it's gonna. I think it's gonna complain because the compiler is gonna look into every branch and it's gonna see that, oh, it's this. The value does not have a field called items because value can be anything and not just an array list, even though we have an if here, which is actually a comp time only function. But it doesn't really, you have to wrap all this in like a comp time thing and then have a, you could return a function like we're doing down here somewhere. Here. So you would do this, you would have a comp time block which returns a function that you then run, and that seems to work with the compiler instead of having the logic directly in here, which you can't because this is comp time. You would return a function that is based on the types. So then the compiler would see that, okay, this is the actual type that you're using, and then it all works out. So but anyway, let's do that later. I'm just gonna try and figure this out like this first. So now we actually handle the case of the array list, which is basically the only case which is gonna be handled like this. And then but however, all the places where we return stuff now, well, okay, we need to serialize the children as well here, so recursively. So we're not doing this stuff. What we're doing is we're gonna return, or we're gonna wait. We are going to make the struct here. So we're gonna make the, let's just call it object, whatever. We're gonna make a thing that is the type of t, and we're gonna set it to undefined. Then we are going to that's the type of the field. So we're gonna say the object, the field. Oh yeah, and now we actually need the field as well. So yeah, we don't need I now. We can just say field directly. So field on the value with field.name. No. The field on object, this will be equal to serialize allocator, and then field access on the original value with field.map. There. I'm not sure why I'm hitting searching for errors, because yeah, I guess I just want to make sure that there's no weird stuff going on here that's gonna crop up later. Okay, so now we're making a new object. We're populating each field with a serialized version of that field, and then we don't actually need this type here. We can just remove this type. Okay, and then we simply return this object. There we go. And that's the structs, I believe. Yep. Now we have arrays and pointers, optionals and vectors. I think this is going to be a bit more tricky, maybe. I think this one is also a little bit tricky, because technically a union is not the same thing. Maybe the union also needs a separate... Because can you actually make a union like this? I think you have to use like something else. Yeah, this doesn't make sense for a union. This union is only one field. So I'm gonna take union out of that, and we have to actually go through this manually. But if T is a union, well, it is here. Value is the union value. So we could copy value. No. There is this function, active tag, but I've never been able to actually use this because it's like a mix of comp time and runtime. It's like I've never been able to actually use this. But in theory, you would put the value in here, and it will give you the active tag. So it just coerces it like this, like a type coercion thing. Okay. So now we should have it the tag version. But then when you want to use it, I want to use it like this. I want to like return and then union init basically. And then the return type is going to be the wrapped type of this. And then the name is going to be the active, wait, name. Well, yeah, it's going to be like the tag name here. And that is actually has to be comp time known. So we will probably have to like loop through all the things and yeah, do that. And then the init expression is going to be serialize the inner value. So it's going to be like this. I thought it was a function to get the yeah, it is at field, so yeah, I think, yeah. Okay. Something like this. So you create a new union value with this type, so the wrapped version of the union. You would provide the tag that it's gonna have, and then the value of the tag inside. So, which is just calling serialize on that. Okay. So we don't need this. I don't think. Let's remove this for now. Right. So we don't need you. Okay. I'm pretty sure we cannot actually use this yet, but so that's union. Yeah, this function is way more complicated than I first thought, and it's just yeah. If just the JSON library, if they just had all of the, it's just the array list that are the problem really. If they just had a convenience function or convenience flag or something that you would say, okay, turn array lists into arrays. I'm not sure if the new version actually has that. That would be really cool. But from what I've searched online, there is no obvious solution to this. I mean, sure, you can use array lists unmanaged, but you get this extra struct stuff like items and capacity. You don't want that. Even though it works, it's like, well, yeah. Because now I have to redo all of my animations and this, like it. I have to like I mean, sure, you can write a script that inserts items and capacity, I guess, but just not right. This was a small fun project because I've been dealing back and forth with the JSON serialized stuff with array lists and stuff. So because another sort of quote unquote solution would be to not use array list and just use slices, but then every time then you would have to like implement like adding new and removing manually instead. And sure, most of the stuff actually has like functions for adding and removing, but I don't know. It just feels like this should be an easy solved problem, but it's not. It's like a small step to actually do it. But anyway, so it's like if you Google on Zig ArrayList JSON, okay, I don't know what that article was. Stringify, Stringify can handle arrays, but not array lists. Yeah. Should probably just pass to the Stringify, but I mean, what's wrong with Stringify and slicing contained in an array list? Because you have to do it on every struct that has an array. You have to like specify that that's what you want to do instead of it being built into the Stringify. This is just a common pattern, I guess. Like if they want you to use array lists, why is it not easy to work with when serializing? If you're stringifying an array list, you could instead stringify the internal slice instead. Yeah. So if X is array list, stringify. Yeah, but if you want to stringify an object that has array lists, what do you do then? It's if your stringify a struct that contains arrays, the only way I know of being able to stringify it is to provide a custom JSON stringify method to your struct. Yeah, and I don't want to have to do that for every struct. It's just, yeah. It's like, okay, I get it that it's like hard to detect also if it's actually an array list. It could be another struct sort of that is the same thing, maybe. So couldn't you do equal in of types? Can you do equals on types? Wait, where did I have things? What the hell is this? I'm pretty sure I had like a thing. Yeah, here we go. Okay, so I'm just gonna say if array list I'm gonna try unmanaged. Okay. Array list of u32 is equal to array list of u32. Then well, I guess we could just do this. Okay, and then let's try, I don't know. What if you have like a type that is almost exactly the same, but yeah, just named different, like you copy this entire copy this. Wait. Copy this and then just name it something else. Will it be the same? Okay, so the result is that yes, you can do an equals, but it's probably not, I don't know if it's guaranteed. So that means instead of doing this thing here is array list. Well, the thing is, well, we could what we could do, we could look at the item, like the child type. Now this returns the type, so it should probably be that. And we know it's a thing, so we do this. Okay. Then we could simply say if t is equal to that, right? And then we don't have to do this. That would be, in theory, maybe more. However, we could also do, we could also have, like, let's say you're using the array list version or the unmanaged version. So we could do, or not t child type. We could do that. So then we capture both array list and array list unmanaged. Okay. Now what? Wait, I totally lost the thread here. Oh yeah. So we did that. Now, what's the thing? Right, so let's go in here and see how can we serialize this now. So what we do is we say this, the wrapper is going to be like JSON.serialize. Oh, we need allocator as well. So okay, we have to change the interface here. I mean, it's not that big of a deal. So let's add allocator, and then this is going to be persistent data like that. So now we should have a wrapped version. But the thing is, I think also this is a bit of a problem here when we have this serialized version. No, because we're writing it out into a file directly. So we can actually just remove, we can deallocate this directly. So what I was thinking is we create an arena and this is the child, and then we get the arena allocator. In the end we wanna deinitialize the arena, because we're gonna get some allocated stuff from this serialize function, which is hard to track here. So we're just gonna wrap it in arena. That's gonna keep track of everything, and then in the end we're gonna deallocate everything. So the whole object, all the allocations are freed. And then this is the arena allocator. Now we have a wrapped version that we are properly deinitializing it as well. We can stringify this now, which will stringify it in such a way that our array lists will become arrays. Okay, so that's the stringified part. We also need the deserializing part, the parsing part as well. So, and we're not even done with this whole thing here, the serialize function, because we have structs, we have unions, well maybe. We don't actually have compiler errors, so that's strange. We should get a whole bunch of compiler errors. And this is actually not a JSON array list, so this is not an issue anymore. Okay. Ah, because it's a problem here. Okay, so serialize this also needs allocator. And pass allocator to save as well. There we go. And now we need pass allocator. Here. Oh, this needs to be a var, I think. Yeah. Okay, here we go. Now we get some errors here. Value of type ignored. What? Oh, okay, so if we don't have this, we wanna, I think you can do this. Okay, yeah. Okay, now we're gonna get a whole bunch of errors. So what's going on here? Expected bool found type. Oh, equal to T. Serialized wrapper. Expected type found question mark type. Okay. I'm gonna go ahead and do that because we know it's an array list, so expected built-in type found type int. Okay. Right. So do we just wrap this? Keyboard ASMR. Yeah. Welcome. Unfortunately, I have to go soon, but in a couple of minutes. But hope you enjoy the stay. So maybe I need to make a union here. Okay, let's do. Where did we do that? Up here, I think. Yeah. this, wait, yeah, this is E. No, it's not. Actually, I think we get the tag here. Yeah. So that's the tag. And now we can use that. And the, wait. No, not serial numbers. This is gonna be E. Yeah. Evaluation exceeded 1,000 backwards. Okay. Wait. Right, so now we don't need to wrap it. Now we can just do that. Wait, no, this is a built-in type. And then we do type like this. Okay. So we're constructing, basically taking any type, we're constructing a new type with the content of the thing here. Wait, aren't we actually just returning the same thing? So wouldn't this be the equivalent of T, right? This has to be, yeah, I think so. Okay. What else do we have? Cannot assign to constant, but it's not a constant. Oh, this is a constant. Okay. Okay. So. Okay. So let's do struct view. So can you? Okay. Let's try and do this then. Can we do equals to built-in time struct fields? Can you do that? And then we just populate this. Let's just try this. Fields I. Can we just set it? Cannot assign content. Okay. So both the values inside and also the actual item is constant, I see. So you would have to say this, that, right? Yeah. Okay, so that is allowed. So what we will do is we will set this to empty. And then we have to construct a field here, which we can do with wrap field. So this is going to be fields I like this. And then let's say we do these things, but we have to do them on wrapped field instead. And then we say wrapped struct of fields equal to wrapped struct of fields plus plus, and then wrapped field. So now we're building up a new com-time array here. Okay, what's happening here? expected indexable found blah 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 blah. So do we have to put the thing there, or do we have to do this? Okay. Right, and then we have the same issue as we had down there. So this would, well, it's just gonna be type and then struct equals to this. Reify structs must have no declarations. Okay, so we'll just strip it of declarations, which we can do here. And there we go. Okay, it feels like there's a long way to go here. This is probably not worth it in the end. So, but it's a bit of a fun to explore what the comp time stuff is capable of here. Expected type. Okay, yeah. So this is the same thing. But here we actually have to use the, I think, yeah, we get the tag here. And then this would be a union init. The type is wait. Yeah, the type is this, right? Serialize wrapper T. And this is tag name tag. And this one initial, yeah, this is just gonna, this is wrapped, right? Oh no, oh no, again, this is, right, this is type. That's right. There we go. Okay, what's wrong here now? Expected struct field found unify. Oh no. Okay, one way is to just copy this, I guess. Wait, or we could maybe take the type somehow. Yeah, I'm just gonna say type of fields is gonna be, okay. Right, it's gonna be meta element of type of fields, right? Ooh, and then also this one. Okay. So same thing here, we can do union init. This is going to be a type. And let's just do the same thing. Tag name, tag, expression is going to be wrapped struct. I guess we could call it wrapped, since it can be either or. Okay. Tag is here. Okay, now we're up to serialize, but there's still some issues down here. Okay, we got, okay, comp time dereference requires to have a well-defined layout. I've never seen this. ComTime dereference requires nullable of JSON serialized wrapper timeout tile source to have a well-defined layout. Ooh. So it's actually running through it now, and it seems to work, but there's an edge case here that doesn't really work well. Interesting. Okay. Okay, I have to take a break here. So I'll be back in soon. So BRB for a bit. Okay, I'm back. Okay, what's happening in Zigland here? Right. Right, this one. The reference requires serialized wrapper to well defined. So I'm beginning to think that this was down a rabbit hole that leads to despair and wasted work. Well, it's not that bad. I mean, you do get some more intuition about like comp time stuff, but I mean, we're almost there with at least this type thing. Then you would have to do it with the serialized. But I think if the type works, then there's a good chance that the value will work as well. But well, this is a good sign though, because it shows that it's actually running through the type and it's doing a lot of stuff right, I guess. But it does get stuck on this one, and to be honest, I have no idea what this is about. So it has to have a well-laid... Okay, how much would you bet that we can get anything out of this? I'm gonna bet that we don't get anything out of this. To Google on it, I mean. So I'm just gonna try and Google here. Okay, let's see. Misleading errors, generalization, okay. Misleading error message when attempted. Okay, I'll just show the browser here as well. Misleading error message when attempting to perform comp time. Dereference to pointer whose type doesn't have a well-defined layout when the real pointer value has another type. Let me read that again. Misleading error message when attempting to perform comp time dereference to pointer whose type doesn't have a well-defined layout when the real pointer value has another type. Well, is it a dereference? I don't think so. Okay. Okay, actually, you know what? This part, where is it? If it's a pointer, yeah, we are returning the pointer. So there was one case where I was like, okay, if it's a pointer, then we just return the inner type, but that's not for this part, I don't think. Here I'm doing that, but not up there. Okay, fine. So that's what's not it. Let's see if there's anything else. Generalization of struct union allows to explicitly define memory layout. I was just thinking of what this means. When dealing with data that depends on fixed memory offsets such as MMIO serialization routines, it's sometimes convenient to be able to explicitly define field offsets, especially when they are non-contiguous or have unaligned overlap. Of course, any such a composite type can be emulated with nested structs, unions, and dummy padding fields. Or you could also use other workarounds like indexing into arrays, which with descriptively named const variables, or hiding the logic behind getter and setter functions. However, such techniques are typically hard to read, repetitive to write, and or error prone, making them ill-suited for the aforementioned use case. Okay, so this is just a suggestion. Well, it's in 2020, it's still open though, so but where do... So I was searching for this text. So where does it say that well-defined layout? Okay. Pack structs have well-defined memory layouts. Okay. Oh, so this is, yeah, this is optional of this thing. So if we say, okay, well, I'm not using any packed like structs. I don't know about the layout, like I don't know what this means. Well, I guess this is auto. So maybe it is packed because the only thing you can choose is external or packed. I don't know. Yeah, or auto, I guess. But then it's only valid if the layout is packed for backing integers. It's like if you have a struct of only like integers or numbers or primitives. I don't know. I have no idea. And I have no idea how to fix this error here. It's like the only thing I can think of is trying to change the type. So does it do that for all nullables? Let's just go into the, which type is it looking at? The tile source. So this is the tile map. Let's go here. Let's just add a thing here, which is some sort, well, test maybe, test field, I don't know. And then just have an optional called something here. So yeah, just an optional. Will that become an issue? Right. Now this is where we need to do some comps time stuff, but this is not the error that we're looking at. Yeah, that is for the serialize function. We need to fix this type thing first. So comp time reference requires to have whatever. So yeah, the only idea is to change the type, because I think the tile source is here. Well, we have brush, but that's not important. Here's the thing. This has a nullable thing there. So apparently something is wrong with this. Well, it should be this one. Wait. What happened? Should be this one. So it's a struct, we have tile set, we have a vector, so we have two fields, an array or a slice there, and a vector. So what is the issue here? A well-defined layout. Okay, I'm just gonna see if I can Google this. Zig well-defined layout. What is a well-defined layout? Okay. Well-defined. Packed structs have well-defined. Oh, you couldn't see what I was doing. Okay, whatever. Packed structs have a well-defined memory layout, exactly the same ABI as their backing integer. Packed structs like enum are based on concept of interpreting integers differently. All packed structs have a backing integer which is implicitly determined by the total bit count of fields or explicitly specified. Okay, let me just check here. What default field values? Struct. Okay, so we're in the struct world. Each field pack structs interpreted as a logical sequence of bits arranged from least to most significant allowed field types. Integer field uses exactly as many bits as bit width. Okay. So why would a serialized wrapper version of this be not well defined? The vector will just be the same. It will just be a vector. So I don't think anything of this would actually change, because the children are not serializable. Okay. But there's a nullable there as well. There's a null there. Is that why it complains, or? How? Wait, so we're in here, so to me it doesn't make sense it's nullable here or optional, because we're in the struct part. Right? So why does it say nullable? Comtime dereference. Or is it like the type that is going through might be one of the fields when it complains, maybe? And it's just when it turns it into a struct here that it becomes an issue. So here, like, let's say we have optional. What actually exists on here? Oops. It just has child, so right. What about vector? Yeah, array. Well, it's not gonna be array, is it? It's gonna be pointer. Pointer has a whole bunch of stuff. We have alignment. So maybe if it's a pointer, we want to change the alignment. We have address space. I don't know what that is. I mean, I guess it's where it's gonna be put, maybe. So, yeah, I don't know. So what would need to be changed? Maybe the alignment, but what is this weird to do here randomly? Make this U16 instead of, okay. So maybe it's the alignment that needs to change in case of a pointer. I don't know. Let's just try it. And then the align of, so we actually need the type, so wrap type is gonna be this. No, now this is actually weird. Wait, we want to change the alignment to be the result of this, really. Function returns number of biases should be aligned to for the current match to match the C API. When the child type of a pointer has this alignment, the alignment can be omitted from the type. So we have to, I guess, wrap type. So this is like without alignment. And then we do this. I don't know if this does anything at all. So yeah. Okay, I'll just add inline. Okay, so it is different. I'm not sure where this comes from now, though. Let's see if we run. And look at the error. So it's called from here. 3 times, okay. So I'm beginning to think that maybe this doesn't even work at all. Well, it might work if you're like a guru trying to work this out, but yeah, it was just fun to see if we could actually make this sort of super dynamic thing. I mean, it's gonna be very hard, I guess, to maintain. So that's a really big downside of this. But okay, I think I'll meet in the middle ground. I'll just delete all this, right? And what we'll do, man, we were so close though. I've did we go forward or backward with this? I don't know. I don't know anything. I don't know what this does. It might just crash the whole thing later on. If this does anything, if this even works here. It feels weird. We're defining a type, then we're changing the alignment of that type to be the alignment of this type, and then we're creating a new type again with the same thing, but the alignment changed. But now this is like a sentinel. This is a slice. It's a nullable slice. It's always nullable when it comes to this error here. I mean, I feel like that's weird. Okay, you know what? We'll do this. I'll just comment this out. I'm not gonna use array list, JSON array list, I don't think. What I'm going to do is I'm going to, where's the thing? Yeah, well, I'm going to use 2 functions, which are the stringify and parse. So this is the stringify function, and then I would have to also make a parse function. But we do have this thing, but we need to make a parse function for an object. So actually, I think I'm just going to use this directly and not write value. So the thing is, for every object that has an array list or anything else that needs special case, but just now it's just array list, I'm gonna have to make, so yeah, I'm just gonna show you here. We're gonna go to animation, for example. Here's the persistent data. So already here we have a list of array list animation, and when we have this, so what we do is we create a JSON stringify function, and we are going to use JSON dot JSON dot write object self with that. That's all we need to do. So it's a little bit of a friction because you need to add this if you want a proper string file. And then you also need to add JSON parse as well. So, but this is not the thing that we need to do. But this will also, we don't have self, we have persistent data. Right, and in parse, it's also gonna be return try parse. Let's do parse objects here, and yeah, I think we need to just pass in everything here. Okay, but now we need to implement parse objects. So these are the two things you need to add, and it's generalized, so you can add it to any object, but you don't need to add it to everybody, just the ones that has array lists, and then it will be properly serialized. And now we need parse object, so let's do parse object, and we don't need the type, or do we need the type actually? Actually, we probably need a type. Yeah. So this can be persistent data. You could use also at this to make it very generic. That works as well. So now we can just take this, copy it anywhere we need it, and you don't have to change anything basically. Okay, now the only thing we need to do is implement this to make this work, and also add those two functions to everywhere we need them. So how do we do this? Well, yeah, the inverse here. So this is going to be a bit tricky, I think. It's like we're gonna have to do the same thing that inner parse does for objects. So if you search for struct here is the function for this. We're not gonna have a tuple, so we can skip that. This checks for JSON parse function. We don't need to do that for this because we're calling this from a JSON parse, so it's gonna be like an infinite loop. Actually, well, yeah. So we're not gonna bother with that. And then we actually need to do these things. We need to have object begin, and then we need to I'm just gonna copy all of this. And yeah, the parsing part is way harder when doing an object. It's almost easier to make a wrap type. So I'm going back to wrap type now in the idea. You make a wrap type, you actually parse that type instead. The type will match the serialized version. But that won't work because you can't, or will it work? Actually, that might be the solution. Wait. Okay, hang on. I'm gonna make this type. Yeah. It's gonna be this, but it's not recursive. Wait. Yeah, it's gonna... Let's take this. And I'm just gonna... So I'm gonna make a serialized object shallow we are not calling that. We are not calling this. Wait, or yes, we are actually. But then it's gonna be like else. Unions are not included because we're only looking at a struct. And then we have like else. We just return that thing. Okay. I think now we might be onto something here. Is a realist T, we return that, so that's the result. And then we make a new, but here's the struct. Yeah, but that makes sense. Yeah. So we do all this, change alignment, I guess. We do serialized rep, so we do this to get that recursively on the fields. Well, it's gonna be recursive. Wait. It's not gonna be recursive into the array list. It's only gonna be recursive in the structs. That's bad. I don't want this to be called if it's not an actual array list. So we don't want to call this on the fields. Only if it's an array list. So I guess actually we don't do this here. We do it here. So we get the field type. Let's do this. That's the field type. So if the field type is an array list, then this wait, what am I doing? No, this equals to that. And then if it's right, the type is either just field type or this. to look at field type. Okay. Align off is gonna be wrap field.type. Okay. Right, and here we need this, and then this would actually be serialized. Wait. No, it will be T. Yes. So, what does that mean here? So I was thinking that we want the result, or we want the JSON type, the serialized type is going to be serialized object shallow of T. Okay, that's the serialized type. Then we're gonna parse that. So we're gonna do an inner parse, serialized value, parsed. It's gonna be this inner parse, and then this is the serialized type. I mean, I guess we can just say this directly. We don't need this alias here. Okay. So that is serialized. Okay. But this is, I guess this is not parse, it's just serialized value or object. Okay, so now we got the serialized object. But now the problem is, how do we turn this into the thing? So, I mean, we could just go through all of the fields of T and check is array list, if that is the case, then we want to parse it with this. No, we don't want to parse it. We already have parsed it. So we want to do, let's just remove this. We want to, oh yeah, so we create a new thing, which is the parsed object. And this is a T. We set it to undefined. Now we set object, and this is going to be field name is equal to it's gonna be, let's just assume that the type that we want to make is an unmanaged array list. So I'm gonna say this, okay? Now we could make technically a compiler error if it's not an array list unmanaged, but let's just do this. So we'll just assume that we're only using an array list unmanaged. And what will this field then become? So we need the element type. So this is going to be the element of array list of field.type. And we initialize with capacity, and the capacity is going to be the value. So let's do serialized array. It's going to be at field serialized object field.name. So that's the array in the object, and the capacity that we want to do is array length. Okay, so now we have initialized the array list and allocated it, and now we can do parsed object field name. Well, we can simply loop through serialized array length. So we loop through the array. We access the array list here, and we can do append assume capacity because we know we have the capacity, and we don't need, I don't think you don't need allocator in that case. So now we do, yeah. No, okay. This is not going to be recursive now, because, or wait, maybe it is going to be recursive because the inner parse will parse. It will look for JSON parse, yeah. I was hoping that we could make this recursive without that, but no, I don't think so. You have to specify the functions. I guess you could use like using namespace and import the functions like that. That could be used, but I know that that's going away, so I don't want to get stuck in that pattern anymore. I already have that. But anyway, let's just continue here. So we have append assume capacity. Here we simply put in the element. And what is the element? Well, it's just going to be this item here. We need capture indexing as well. Okay. So where are we? We are going through, yeah. So now we're going through all the fields in the struct. We are checking, is it an array list? In that case, we get the array and we set the target to be an array. We're initializing an array list, and on the target we're going through each item and we're appending the item into the array list. Okay, makes sense. Yeah, and then the thing is with inner parse, it's gonna work here because it's gonna inner parse this shallow thing. But if you have a child with array list or another an array list with a child that has another array list, then if that structure has JSON parse on it, then that will go through this same procedure, so you will end up with the correct thing in the end. Okay, like recursively here. But you have to specify JSON parse on each struct with array lists. But it was a bit of more hassle than I thought of actually writing this parse function here. So this will initialize the array. If it's not an array list, what we need to do is we need to just copy, just copy over the value over to the parsed object. So it's just going to be field parsed object, and the field name is field.name is equal to field serialized object and field.name. There we go. Okay, I'm pretty sure there's gonna be compiler errors, but let's that's not called public. Yeah, there's gonna be compiler. Yeah, there we go. Okay. Okay. Hang on. Now it's called marked public. So right. So the issue here. It says unable to unwrap null. Why does it do that? Because we know it's an array list, so it should not be null. Well, the compiler actually goes into this branch anyway, even though this could be false, even though it's a compile time check, because we're not in a compile time block. So you have to be in a compile time block in order for this to work. So how do we do this? Well, yeah. That's a question. So we basically, what we want to do is you want to do basically this in a function. So let's try and break this out. So this would be initialize array list. And we need a couple of things here. So we need the serialized object. Let's just put any type and see if we can get away with this for now. We need the field. The field is a comp time struct field. Field. Parsed object. Is gonna be here, so this can be the parsed object. Let's just put n type there, I guess. Allocator. Okay. If we are in here, we wanna initialize the array list with allocator, serialized object, parsed object, and the field. So we'll get rid of all this. Okay. Right. Let's pause in the type as well. So the parsed object should be t, and this one is the shallow t. But they should be mutable, so let's do that. Well, actually this one doesn't need to be mutable. Okay, now we still get this error here. So because we're still like calling this function here, but what we need to do is we need to do this part also in a separate function. So init field, I guess, and here we need content t type, we need parsed object. Let's do same pattern here, serialized object, parsed object is mutable t. We also need contime field type struct field. Okay, now right now here what we want to do is we actually add allocator here as well, so these two functions now accept the exact same types. So what we could do now is we could say comp time we want to have init function equals to this comp time block, and here we are going to break this function, and here we're going to break this function. So depending on this comp time now evaluated thing, we're gonna get init array list or init field. So now it knows, now this won't complain again. It's hard for me to explain maybe what's happening, but it's basically not gonna go through each branch while checking for compiler errors now, even though it might be false. Now it's because this is comp time, it actually doesn't go in here if it's false. So now we can call init function on t allocator, and we just put all the things in there, except this one needs to be a reference. And there we go. Now those errors disappeared, but we do have this weird error here. Function with no void return. Okay, so we should return something somewhere. Yeah. So we'll have to return this object. There. And I guess because this guy is, we could also have this be a thing there, and then we can try here instead of catch unreachable. It doesn't really matter that much. We don't need try there. Okay, there we go. Okay, and then here we can simply say try now. Okay, and that's our parse function. So we're parsing an object from a JSON string using like the JSON sort of built-in, like the standard library. So you get this methods here. You can use inner parse to parse the object. Here we are using a little trick though. So we are sort of modifying the type that we're gonna parse. So if our type includes an array list, then we simply change that array list into just an array, and when we parse, then it's gonna parse it as an array and not as an array list. But then we need to go through and actually make those arrays into array lists back again, and then we return the resulting object here. Okay, cool. So yeah, is this used? Yes, this is used. I'm just checking here. So we're out of errors here. JSON has no memory. Oh yeah, so this is the old stuff here. So we don't do, now we simply, we just do stringify now. Yeah. Well, we do stringify on this one. So, oops. Like that. And now we don't need allocator anymore. So let's get rid of that. That and this and this and that. There we go. Oh, test field. Get out of there. Okay. Okay. So, but the thing remains, though, that we need to add these things now to all things that need that. So I think, though, for convenience, I'm just going to use public namespace because it's less bloaty. So but will it actually work though? How will this become correct? You know what, let's just do this. It's not that much to do, and we don't need to change this. I just want to see if it works though, but let's add it everywhere. It's not that many places though. This one also needs, let's add it below clone. Keep the convention there. Whoops. Oh, there. And do we have anything else? The frame does not need. No. Let's go back. Document animation or persistent data. No, nothing else here. So let's check. Texture doesn't need. Scene probably needs something somewhere. Maybe not. Actually, no. This is the scene entity. Yeah. Here we go. Here's the scene thing. So let's add it here as well. I need to import JSON. There we go. And let's also check out the entity does not have anything. Okay. Pretty sure none of these have like a array list in them. Yeah. Okay. Time map. Yeah, this one definitely should have. Yeah. So let's add this. All right. History. And then time map has it. Okay, same issue here. Oh, this one actually. Yeah, I'm not worried about that. Hello, Flappy. Welcome to the stream. Might be a weird question, but how do you jump word to word or like go down line by line? Well, I'm using a couple of different things depending on like what I want to do. Right, I mean, a lot of the things that maybe this is what you see like this. I can go back in sort of like Vim keeps track of sort of a local history of where you have been, so you can simply go back and forth in that with control. I'm using Control O and I to go back and forth like this. Yeah, and then there's like a bunch of different ways to move inside here as well. Also, if I want to find an error, I press F8. I'm not sure if, I mean, that's just, if you look at the binding. Okay, let me check with this one. Bindings or key maps. F8. So I have this binding, diagnostic auto next on F8. I'm not sure if that's like default. Pressing J makes the cursor go down, but it's very slow. Oh, you mean lower? Yeah, yeah. I'm actually not using those. I'm actually using the arrow keys. But also, if I'm gonna use to this, if you're standing at a curly bracket like this, and then you press on percentage or shift, for me it's shift 5, but the percent sign, you can jump to in between these. So if you wanna select a whole block like this, you can do shift V and then press that. I mean, or if it's separated by like this, if it's separated by white space, like new lines, it's actually a paragraph, so you can use the paragraph text object. So like DAP will delete the whole thing, and then you can also insert it here. But when I did this, I'm using like I'm pressing end. So I'm doing this, pressing end and then percentage sign to get down like this. But what you could also do is, which I haven't been using a lot, you could do curly brace, closing curly brace, you go to the next empty line. So that's also very efficient if you want to jump, if you want to jump like that. Let's see here. But I'm not using that much. I haven't gotten used to that. It's hard to change these habits. One thing that I'm also using is like, when I know that if you stand here and you want to replace the right object here, let me just show you visually this part. What you can do is you C for change, and then inner, I for inner, and then word, W for word. So CIW. You can do this, and it doesn't matter where you stand in the word to do it. However, I'm actually not using that most of the time. What I do is I press B to go to the beginning of the word, and then CW, because for me that feels, I guess, more familiar to me. I haven't really gotten used to pressing CIW. I have to move my second hand in order to do that. So I'm pressing B for back and then change word, because if you do change word in the middle of the word, it's gonna be this, so you don't get the beginning part. So that's actually one thing that I see people, oh, you can use inner word, but for me, I'm not actually using that. Revert, you mean undo? Redo? So if I do this, I press escape, I press U to undo. U for undo. And then if you want to redo, you can do, for me it's Control R. Yeah. Yeah, no problem. But I'm, yeah. You always find out new stuff about Vim. It's fun. I'm trying to switch from VS Code to Vim. Okay, cool. You know, there's a. Are you using the plugin? There's a Vim plugin for VS Code that has like a lot of the motion stuff. If you want to do like a soft, what do you call it? Conversion. What? Okay, so yeah, we were adding these to the different things. Let's see, time app. Is there anything else that has the things? The layer has, yeah, it has tiles. Okay. So we need to add it here. JSON. Wait, no, this is lib JSON. Okay, there we go. Yeah, I would say my productivity probably increases a lot when using motions. So I mean, I know in VS Code there's like a lot of the things that you can do in Vim, which is sort of the first things you learn, do exist in other forms in VS Code as well. So you could argue that you can get a long way with that kind of productivity with VS Code as well. But you could just do so much more with Vim. Just being able to like combine learning the text objects or the motions and being able to combine them with other commands is like, it's very, very interesting way to do things, and I like it a lot. Although I would say it's pretty hard to get new habits at this point. Hello Asriel, welcome. How's it going? Okay, so that's time map. Yeah, persistent there. So we have time map, texture, scene, and animation. We already fixed. So okay, well, now our old animation is not gonna work anymore, so this is gonna actually crash, I think. Yeah, because it's trying to read a JSON file which is in another format. So I think what I'll do is probably, well, actually I could just delete everything. Let's just delete everything in here. Right. Okay. Going good. Haven't heard back from my tester. What about you? Okay, cool. Are you making a game or something? I'm doing good. I'm just improving my editor a little bit here for my game. So we're currently working on JSON serialization and getting that back up and running. So I have to. Okay, it's trying to. I think it's trying to load a file and it doesn't exist. Yeah. So let's see, where is this happening? This should probably. Oh, it's trying to actually get the texture that doesn't exist. Wait, what animation is it trying to load here? Apparently. Okay, hang on. I want to see. When we restore the session, we should like catch these kind of things. So here, for example, we have here we have open editor file path. So we open this editor, but if this file path doesn't exist, we request the document, it doesn't exist, so nothing happens, I guess. Right, let's see. Where are we doing this? We're doing here. We're catching, could not open, and then we just remove it, return null. So okay, so we're not actually doing anything in case we don't get a document. So I think we don't want to set the current editor, and we don't want this editor at all, I think. So we'll just remove the editor again. Editors. Let's do swap remove. It's gonna be the only editor anyway. Yeah, let's do a swap remove on this. And then this is gonna be null. And then we return. Okay, so now in theory when we open it should not crash, hopefully. Okay, we get this error, yeah. File not found. Great. So now we have no things. Yeah, no problem. I made a game with a F&F mode and it out right now, but let's fix some bugs. Okay, cool. F&F, what is that? I'm trying to think. F&F. Fortnite? No, I don't know. Okay, let's try and create an animation. Open it up. Let's set the texture. Make an animation. Setting the size. Okay, here's our animation. We will save. Close, reload, and unexpected token. Okay, cool. I guess. So let's have a look at the file. FNF means Friday Night Funkin'. I'm sorry, I don't know what that is. It's on my channel. I'm in love with the end song. Okay, cool. Yeah, I don't know what that is. Is it a game or like the FNF, or what is that? Okay, let's see here. Here you can see animations is now saved as a simple array. Very, very nice. And the frames as well. But why did it complain? Is the question. Unexpected token. Okay. Let's check the deserialize. I didn't change anything here, right? We're parsing a persistent data, so that should be good. A beat games. Oh, so like Dance Dance Revolution or something like that, right? Oh, you have an arrow coming from the bottom of your screen. You need to time the notes to your note box. Oh, I was thinking you were talking about the mouse pointer first, like on my screen. Yeah. So it's like a rhythm game. Those are fun. I used to play Stepmania on the PC, like just using the keyboard, like a long time ago. Cool. So it's yeah, okay, cool. So it's done. Congratulations. Are you gonna release it somewhere, or is it is it like, is it, so you say it's a mod, so is it something that you can put up like on a marketplace or something, or okay, deserialize. Okay, let me check the error message again. Wait, that's not the... Okay, error reading file, unexpected token. It's out now still. I'm keeping an alpha until making sure it's down for beta. Okay, cool. Kind of a mod logic, you can look it up to play it. Alright. I haven't heard of those things. Although I don't know what FNF, or I haven't played FNF, but... So it's like a main game, or is it like a platform, or is it like it is a game that you make mods for and put up there? I guess most games probably have like a mod platform nowadays, or most games. Like, I don't know. Well, Steam has like workshop. It's a main game. Okay. Yeah. Okay. Cool. So what does the mod do? So FNF is like is the rhythm game, right? Or is your game the rhythm game? I guess I would have to look this up. I'm a little bit curious. But why would it complain on unexpected token here? Okay. Yeah, I get it. It stands for Friday Night Funking, but I still don't know what that is. Like, you said it's a game, and you're making a mod for it. Or, wait, you didn't say it was a game. Okay, I have to look this up now because I'm confused. Sorry, it's I've never heard of it, so. Friday Night Funkin'. Wait, I don't want any sound playing. Okay. It's a game. Okay, so it is a rhythm game. Okay. Right. So what is your mod? What does your mod do? Is it just like but is it like additional content or something, or does it change the game? Or let's see. Oh yeah, sure, because usually those kind of games you can like buy like songs and stuff, right? So is it something like that? It's a rhythm game. You place the right side, aka BF. Models of week 3 remake, meaning better sprites, better music, remixing music, new models. Okay, cool. Nice. Good job. Hope it works out. So I was gonna check if we actually put parse on everything here. Yeah, we have parse here. We do JSON parse object. So the serialized part works, but not the deserialized. So why would that be? Wait. What if this is a pointer? But it's not a pointer because it's at this. Yeah. Yeah, I'm close. Oh, one more. I thought I needed 3. I've been checking this. Okay, cool. I got 2 today. Nice. Yeah, just one more. Man, it's been... I never thought I would actually get like one or... Yeah. But really nice. I haven't really made like YouTube videos lately. I've only been streaming. But I am planning on doing more, more condensed videos, so that it's not only like the live stuff, like showing the progress or showing what I've learned in Zig and stuff. Because I think that is what people are mostly interested in, like learning Zig. I think that's what, well, at least from the comments that I've gotten and stuff. You got 7. Nice. Yeah. Yeah, and I mean, I think it's just a matter of keeping it up and being active, and I think it... I mean, potentially it's gonna take a while, but potentially we might get, you know, the magic number. Made my channel saying, man, I'm gonna be the first dev content creator with 0 subs. Everyone starts at 0. But it's I'm surprised how because it's kind of niche, right? There's not that many that's gonna be interested in this sort of thing. So for that standpoint, maybe it's not a smart thing to specialize in. But I mean, it's not. It's mostly. I mean, you have to do the thing that you think is fun and interesting. How do we fix this? So. Like, I don't even know. Well, let's see. How can we get some info somewhere about this? Wait, do we have a memory leak as well? Or is this just... Oh yeah, we have memory leak. No. Request document. Key pointer. Oh, okay. This one? Wait. But how? Okay, so we have to go into the thing and then it leaks. Right, so we request a document, it does exist. Then it leaks. When we exit, why? Oh, are we not taking care of these keys? I thought we did. Yeah, we are. But yeah, it would be really nice if this could be like a job. I would really love that. So what kind of are you showing, like the progress on your game and stuff? Also, what are you programming stuff? Like what language do you have to use in that, or could you? Is it C++ or something, or? Okay, I'm trying to find my way here. Wait. Here. So why is this? Oh wait, if it fails. No, but we do get it. We should have gotten a document. But here it's not actually. Is it serialized here? Yeah, we are deserializing it. Okay. Psych engine. Okay, haven't heard of that. Here are the steps. Place your main files in the game, locate and open a Psych engine folder. Place your menu files in the game, locate the folder where you place the XML PG files. Okay, so you put a bunch of files in there. Okay. Character for when they're in the menu, place your PNG files you generate for your character. For when they're in the menu, place your icon files in the game. Prepare your character. Okay. So there's no programming or anything like that. It's just, well, I say just, but you put a bunch of like assets. If you want to call XML. Well, technically, you could structure XML in the form of a program. So you could parse XML as code, I guess. But okay, cool. I don't understand. 344 request, yes. 1381. Wait, this is different. Oh, this is down here. Wait, this is the value of the editor. Oh, it's a different one. Right, so it. Okay. So we duplicate the key. I would try to set the value pointer. Wait, and then in here we do an initialize. Right, okay, so essentially we need to catch this error right, because if there's an error we still have initialized something here, so we need to like deinitialize. Yeah, okay, we need to do document deinitialize and then return this error. Oh yeah, try. Remove the try. Okay. So now the document is no longer a problem. Now this though, let's do that after so we don't have to worry about the error. We don't have to deinitialize it after that. Okay, let's try now and see. There is coding, okay. When doing game background songs. Okay, cool. What language is that? Could not open document. Expected to. Yes, okay. And now there's no memory leaks. Okay, cool. So back to the problem that we had. Could not open document. I wish there was more information. Like how far along would it did they go? Is there a way to do that? So we get an error somewhere here. Now this will bubble up somewhere. Wait. Where is this? Here. So we're catching the error here. Now, is there a way to know? Parse error. OpenFL hacks FLIXRL hacks flexurl OpenFL. Okay, never heard of those either. OpenFL. Oh, cool. Creative expression for desktop. So it's like a UI language? No, application video games. Or I guess it's more than UI, maybe. Huh. Papers, please. Made using this? Okay. Published to native C++ on desktop phones, tablets. Okay. Cool. Do you like it? Or is it nice to work with? Hacks Flix RL. .2D game engine, okay. Hacks Flixel. Okay, Hacks Flixel. Cross-platform games. Okay, cool. It's nice to know some stuff that's being used out there. Meanwhile, I'm using the tedious method of creating everything in a programming language here. That's not widely used, but it's fun. Okay, so I was gonna check here if there's a way to get more information from the error It's just trying the thing. Maybe you could get maybe something from the scanner. Complete input JSON reader. So we have the reader. Maybe the reader actually has some information. A reader has a scanner. We have a buffer and a reader. What is this? Reader type. Okay. What about the scanner? So we have cursor. We could look at the. We can see where the cursor is, I guess. Diagnostics. Enable diagnostics. Okay. Maybe we can use this. So it has line number, start cursor, total bytes. Okay. Well, let's see what the cursor says. So let's do a catch. Error parsing JSON ends. Wait, it's the other way around. Invalid format string D for type out of what? Oh, it was the old error. So you have to go in and save, and then the thing will flush out. Okay. Okay, so let's look at the logs. Reading, parsing at 108. Okay. So let's open up the JSON file and we'll go. Wait, how do. Okay, I have to Google this. How I go to a specific sort of byte offset, I guess, or character offset. Character offset. Go to. Okay. Go to 108. Name. Ah, okay. Okay, I didn't see this. So this is wrong. Why is it like this? That's weird. I'm pretty sure this worked before. Okay, let's go animation. Yeah, this one. So this actually, this should have JSON parse and stringify. So I'm not sure why it doesn't grab those. Where is stringify? Right object. Wait, Ah, it's a struct, so it does write object. This is an issue. Okay, I don't want to do this, I don't think. I don't want to do that. Because I don't need this to be recursive. I'm gonna prevent this from being used from outside, and I'm gonna remove this because this doesn't take JSON parse into account. And I don't want to build that into the function because it's gonna be an infinite loop. So I will remove that, and then this one will take JSON parse into account. Okay, so we have to remove this file now and try this again. Oops. Okay, you didn't see. I forgot to remove that thing, but I think I've fixed it, so let's try this again. Set the texture there. New animation. Okay, I'm just gonna do that. Save. Go back. Exit. Go. Okay, there we go. Hey, it works. Cool. All right. So I have to test the other types of stuff as well. Actually, well, okay, let's create the scene. Let's create a time map. And I'm just gonna do this. Let's save. Go to the scene. Time map. Wait, where is this? There, projects test. There we go. There's the time map. Let's add this one. Hit play. Oh, it doesn't work. Okay, so there might be some discrepancies on the scene. Wait, why would that? Oh, because of the array list. Okay, I have to do the same thing in the game code as well. So, but we'll get there. So, but now we have a time map, we have a scene, we have an animation, and we can quit, reload. And we are loading things in again. So very nice. That all works. So yeah. Okay. I think let's go to the to-do list. So yeah, so the deserialization and serialization now works. For things, where's the animation? There. Okay. And this is now, so okay, so last test for this one. So I'm gonna copy the animation again. I have to rename it because it didn't match. So I'm gonna, this is now an old, or the existing sort of animation. Oh, cannot open unknown field again. Okay, unknown field. Oh yeah. Okay, I have to massage the data a little bit. So let's do projects. Pisling. There. And so yeah, we don't, for example, we don't have texture scale. the file name is actually called something else. It's called texture path. I think that's it. Okay. So let's retry. There we go. Now I opened up this old thing with all of these things here. But as you can see, also the origin. Wait. Why is only the first one working? Okay, there's something weird with this. Some of, like the first one seems fine. This one has a weird grid size. Was that always like that? Maybe. I mean, it seems to work most of the time. So climb. Oh, it might be that these first things are. Oh yeah. Okay, it does work. I'm just I just didn't remember that I've actually modified this a lot. These are super old animations that actually doesn't refer to the correct stuff anymore. They are not used anymore, so that's why I forgot that. So we have this climb where this works. We have, yeah, so it all works. The only thing that doesn't work yet is the origin. So I don't know if I have anything in here that is actually that. So what I will do is I'm gonna copy the monster. I think this guy has texture path. Okay. There we go. So we should have some animations like this one, maybe. Yeah. Well, actually, maybe the origin doesn't really matter that much. Is it really so slow in the beginning? Oh, maybe. Hey, welcome back. I don't remember. Oh yeah. What about the program languages? Are they good, or do you think they are nice to work with? Okay, so I think if you look at this, we can see the origin is like -16. I think the only way. Oh yeah, one thing that I want to fix is there's no scroll bar to the right, so you can't scroll here. Okay, let's fix that. Animation. This is gonna be the frame window. They are for FNF and 2D games. Okay, cool. But you need to make sprites, right? Yeah, sounds cool. Have you worked with any other programming languages, like C++ maybe, or anything like that? Let's see. Animation frames. So here's the list box. Here's the window. So you can specify flags. Always horizontal. Yeah, let's put this to true. I'm not sure why it's why it doesn't show it when the content is outside, like it's overflowing in web dev terms. Yeah, so now you can, whoa. Okay, that's weird. What's happening here? Oh, the list box has a thing. Oh, this one also has. Okay, this is weird. Is that why it's like... Okay. Let's see. The list box, do you have flags? No? Yes, they're listed within my game. Okay, cool. Set. I was thinking if there was a way to disable the scroll bar. I guess I could just make the thing larger. So the size of the window, so the height, wait, it's gonna be over here, or yeah, wait, so you can't, oh yeah, you do this, set next window size. Let's do always. The width is something. I'm not sure actually. I don't really want to set the width. Okay. Can I get the next window size? Okay, first none once appearing. I guess we can do once. But I want it to be always, but I don't know what the width will be. But let's just pick something, I guess. We know that the width of the sidebar is like 300 pixels, so we could get screen. Okay, let's do screen width. And we have to make it a float, so it's gonna be, yeah, I'm pretty sure it was float from int. Oops. Not that I used, I was the director. Okay. Oh man, how many people did you have? Seems like got a couple of people there. Age. So the height. Okay, screen width. Okay, let's do -300. This is a magic number here, but whatever. Height is gonna be. What is height gonna be? Like the. It's gonna be like scale times the texture height or the grid height. So it's gonna be animation grid size 1. But this needs. Yeah, this needs to be floaterized. Okay. Let's see what kind of size we get now. Needs to be a little bit higher. I guess not by much. Well, actually. So let's add, I think 24 is the size of the bar. And then there's like padding. So I'll add, I think like 4 pixels, 2 pixels padding. It seems like more than 2 pixels. Well, let's see. Yeah, we definitely need more. Even this is like, so what would it be? 4 times 4, like 16? Oh man, 8 plus the engines, 3, more than help and gift. Okay, cool. Wow, that's a lot. Or I mean, yeah, for, or I don't know. I'm not. I haven't. I've been in making games that long. I haven't made one game yet, so. But to me, it feels like a lot. I guess that depends on the needs and stuff. Why is this so? Okay, how much would this be? Like, let's just add another 24, I guess. I'm not sure if there's a way to actually, because it feels like there should be a way to actually see more, like, still not enough? It's always like this a little bit down. It's like the list box, the height of the list box is larger than it should be. So let's try and set this size of this one. Next item. Oh, here's the height. So the list box height is set to the content max, right? So let's actually make this a variable, and we will set this to, I don't know, remove 24. Wait, it is mutated. Oh, what am I doing here? Minus equals to. There we go. Wanna hear my description? It's funny. Sure. Okay, so a little bit more. I guess we could increase. No, actually we should decrease the list box height. You can see that it goes down here. This background here is the list box. So let's just just double this and see what happens. I'm not sure if it's gonna like eat into the images. Yeah, it is. But this one still goes down. Oh, that's in the list box. Okay. So we need to add a couple of pixels. Let's do plus 16. The goal of this web optimized port is to make FNF and this mod more accessible to players that can't otherwise play it on their Potato PC, on a Chromebook, on their Mac, on their Linux, or simply can't run the exe files on their computer. Also help save hard drive space. Please. So make sure, I'm not sure if there was something missing there. So make sure to also get the PC version if you have a PC. Alright. So, okay. So you're also like optimizing the whole game. Okay, so we need this to be a little bit more. I'll add 8. I mean, yeah, I'll remove 8 more from this. This is kind of fiddly, but hopefully we get to a good... how many pixels is there left? Like 4? Yeah, alright, nice. That's appreciated. Okay, but now this is too much here. I don't understand. Wait, go back here. Am I scaling it? No, I'm not scaling it. Yeah, it's too much now. 16 or I guess 12 maybe. So that's what, 36? There we go. That's the sweet spot there. I guess we can try. Okay, I don't know what's happening here. Why does this like... Is this like a bug in the UI library or something? Maybe it's because of the the width is set to the content region max. That doesn't make sense to me. The width should be set to whatever width, like... Oh, maybe that's why the horizontal bar wasn't shown. Like the width shouldn't even be set, right? Let's just remove this and see what happens. Okay. Well, okay. Okay. So if we look here, we see that there's basically no gap between these. So we can just take the width of 1 and then times it by the length. So also I want to get rid of this label here. This doesn't make sense. This label is... I don't understand why they put the label on the right side. That doesn't make sense to me. But hey, it works sometimes, but not always. Okay, so... yeah, the width will be equal to context scale times Also, what is this? This is a float, so we need to do float on it. So context scale times the grid size width times the the length of the frames. No, animation frames, items dot length. There we go. Okay, int cost. Oh my god. It's I32. Yeah, the casting stuff, sometimes it gets a little bit ridiculous, but I guess it's a good thing that it has to be explicit, and it's good sometimes and bad sometimes. Assertion failed. Oh, okay. I know what this is. This is the label, but can we hide the label, or what can we do with this? Like, I don't want to show the label. Okay, let's just put the label in there. Actually, you do like this. You do push string ID, and let's just say animation frames list box, just to have it very. Can you pop it here? Pop ID. Or do we have to wait until the end? Probably we have to wait. Yeah. So let's pop it down here. There we go. Okay, so now we have to set the width of. Wait, where did we go? Here. So the width is list box size 1. No, 0. I also have to make geometry dash game. Called mod or called skeleton shenanigans. Okay, nice. Or a mod, or a mod game, or not the actual geometry dash game is what I meant. Okay, now we can see everything. Oh, except something at the end here. Why is it not the whole thing? Is there like a little bit of padding on these items? There might be. But there is close. I think that's at the edge. Yeah. So it's like 4 pixels padding, I think. So let's add that. It's gonna be like 4. Well, it's gonna be 8 per thing. Wait. No, it's gonna be the length plus Wait, I want to do some math here. So we're gonna have to take this. It's gonna be this plus this times 8, right? So in this sense, we can take this, put it here, and then times context times that plus 8, right? This should be the same thing. Okay, yeah. So this is kind of the width of one item times the length, yeah. There we go. Oh. Okay, I'm not gonna care about that. Cool. Okay. A lot of fiddling around. Let's also I want to disable the resize because it doesn't do anything. Where's the thing here? Resize. No resize. True. A geometry dash game map. Yeah, cool. Is have you played? Are you good at it? It can be pretty difficult game, but really fun. Okay, there we go. So yeah, that works very nice. And here you can see when you click on one of these, we select it, and then you can choose things here. You can delete it, you can change the origin, you can change the duration scale. So for example, if we change this to 10, the first will show longer. Also, why is this one shown like wait? Oh, I see. There's maybe some issue here. We're choosing like the next one. Okay, that's a bug. Where is that happening? A release frame. Right, let's go to document. Update preview. So we're updating the frame to the first, then oh, we're not updating this. Okay, we should actually get this again here before doing anything. Okay, there we go. So you have to update the one because we're changing the current frame. Okay, wait, yeah, that's where we are, and let's just select the first one, set it to 10 times. There you can see now it starts on the first one, 10 times longer. There we go. Okay, now changing the origin doesn't actually do anything, and I'm not sure if we have animation anywhere where the origin actually is different between the frames. That's what I was trying to find. It's all the same. So as long as they're the same, whoops, wait, why did that fail? Think of it as an Elden Ring boss fight. Okay. Well, I mean, to me, it's yeah. I have like a sort of a love-hate relationship of the sort of trial and error type gameplay, because I mean, sometimes I feel like, okay, yeah, I want to get good at this specific thing, but at the same time, sometimes it's not fun to. Well, I guess it depends on the kind of game, because Geometry Dash, you have some leeway of actually trying to react. I mean, the most fun I have in Geometry Dash is when I can actually react before dying, and sort of when you get to a new place for the first time, and you try to survive for as long as possible, or complete the map for the first time, when you can do it with your own reactions and like reacting to the things immediately, instead of having, you know, a memorize the whole thing to actually complete it. To me, the exploration part is the fun part. And what was I gonna say? Yeah, so it's like, I don't like it when games, so it's like, okay, you choose this path, so you die immediately, and you don't get any like double take on it or anything, and then next time you have to just know that you have to choose the other path, otherwise you'll die. I don't like that. I like it when it's like you can actually try to win by reacting to things like dynamically. But it could still be extremely difficult and stuff. But I feel like when in Geometry Dash, when it gets harder and harder, that you get more closer and closer to kind of a trial and error sort of gameplay. But at the same time, it's also possible to react in time as well. So it's like, yeah, it's really fun. You get this rush when you see something for the first time, and you're like, oh my god, I made it, and you know, you get far. But then there's something to it also, to just try to practice and try to actually complete the whole level as well. So I don't know, it's like, sometimes I feel like it, sometimes I just find it boring. But when you can get some really nice rushes from games like Geometry Dash, and then it feels really good. And I guess the same could be said for the rhythm games as well. Although then it's, I guess, you have some good music going on, so it's more fun, I guess. Well, it's the same in Geometry Dash, I guess, as well. It's sort of almost like a rhythm game, but not really, because it's not matched to the music. Well, not always anyway. There are some levels, I guess, that are. Yeah. Wait. So what was the error here? What the hell is this? Flags, mismatched. Did you test the return value? Layouts. Do you have to test it? Did you test the return value? Mismatched. Okay, so apparently sometimes this doesn't work, or I don't really understand. Do you have to put this in an if? Okay, let me check the example here. Yeah, they have an if. Okay, so you have to put this into an if. And then do you have to do pop ID? I think you have to do this. Because I don't want this ID to leak. Okay, there we go. Okay. Let's see. Yeah, but I think we'll be happy there. So I don't think we'll do this for now. Postpone until we need it. Different origin for more than for, I mean, unique, I guess, unique origin for a frame in an animation. I guess you could say. I mean, I don't know. This is stupid. Okay, let's just say it. I guess we could do the reload texture button. That shouldn't be too hard. Okay. Tell you what. I'm gonna make this, and then I have to jump into something else. So let's do this last thing. My game goes from alpha to beta. Nice, congratulations. Finally got my tester back. He said there's no bugs. Wow, that's incredible. I mean, usually I'm used to having a lot of bugs. Let's see. Okay, so reload texture. So what do we need for that? Well, I'm gonna do top down here first. So let's go to layout. Well, we are in animation layout, I guess. Actually, reload texture. We could have reload texture for like a generic thing. Like if we have all the texture, we could technically have a list of all the texture documents and then reload separately. But okay, let's just add it here and we'll set texture. Let's add a reload texture button. We don't need to open it again. We could add maybe a function to context that is like reload texture, and then, well, we need to, no, we don't need to request the document. We could do texture document. No, wait. What's happening here? Animation document. Yeah. And texture. Yeah, there we go. Oh, and this is nullable as well. So I guess we'll have an if. Texture file. Oops. Okay, now we need to implement this function. So let's go over to context. Let's go to request texture so we can do it here. reload texture. And I think basically what we could do is just deinitialize the document, remove the document, and then just request it again. Yeah. So what would that entail? I guess we could do unload document. Or, yeah. Unload documents. Document. Well, thanks, Mental Games. You can join my Discord if I have a Discord somewhere, so you could join there if you want. Although I'm gonna say it sounds a little AI, your messages, just so you know. I'm not trying to be mean or anything. Okay, unload document, context, path. So what's gonna happen here? Well, first I think we'll do request document. I think we'll just request the document first. Yeah. So we'll request it. And then we will say, gotta go, wanted to tell you good luck. Thank you. Thanks for joining. Yeah. And also, yeah, congratulations on the release there. And see you later. And thanks. I'm not sure if I said it. Yeah. Bye. Deinitialize. So we want to deinitialize this, and then we have also a whole bunch of stuff. So we have the path. Now this guy, well, this is all for opening the file as well, but we want to do this as well. We want to, yeah, we want to grab the entry. Actually, yeah, we want to do this. Fetch, remove. Let's do a swap remove. And if there is, the entry is removed, yes. So this one removes it and then returns the thing. So, and if there's nothing, then I guess it returns null. So we have to put in the key, which is gonna be the path. And then, or I'm gonna say, if it doesn't exist, we just return. So here's the entry. and we got the value, and we want to deinitialize the value, and we also want to free the key. And we don't need that. Wait. Okay. So I think this is it for unloading document. We fetch remove it from the cache, or the string hash map, string array hash map. We deinitialize the thing. The space for it in this is also removed here. We free the key, and then it's out of our hands. That's oh yeah, but deinitializing the document will handle, yeah, it will handle the unloading, I'm pretty sure. Yeah, it's gonna call deinitialize on both those. So here, for example, deinitialize will unload the texture. Yeah, cool. Now what we want to do here is we want to unload this document. Then we simply do request texture. Actually, we don't really need to request the texture. We can just do request document. I guess this technically is reload document then. Don't really need it to be texture sort of. Yeah, we don't need this. Let's see. Sure, doesn't really matter in this case. Reload texture. So yeah, let's do reload documents instead. There we go. So now we go back to the layout, and here we go. Here's our reload document. So that's it. Okay, so let's test this out now. So let's go and open up this animation, and I'll open it up in GIMP just a second. Okay, and I'll make some weird change here. No. Not sure if this is gonna make it obvious here. So I'll click on reload texture, and there we go. Okay, now let's see if we get any weird memory leaks or anything. Hopefully not. Okay, cool. Nothing happening there. Cool. All right, so that was pretty easy actually. I kind of expected it, but it's always nice when it goes well, smooth like that. All right, so I think we're actually done with the animation editor. We have basically all the things we had in the original, except for the origins thing, I think, but again, that's not really necessary. There's one small detail that we don't have, and in the original, it's not really that big of a deal. In the original, we have a small like notation for, or a small label on each frame that has different duration scale. So if it's like slowed down for that specific frame, we can actually see that as a little like 0.5x or 10x or something like that. If it's 10x the duration, so you're gonna be able to easily spot which frames are modified in that way. But it's not really, you know, that big of a deal. I mean, it's probably pretty easy to add it. I guess I will add it here. So duration scale modifier label. So I'll yeah, we'll see. But now, so yeah, really nice progress. We have made, with this whole sort of arc that I've been doing for last couple of streams, is the editor sort of work, where we made the assets manager, which has some like a rudimentary functionality, but it works really well, and also a resource system for loading documents and stuff, sharing, you know, resources between different documents. So a scene that has a tile map doesn't load a tile set texture multiple times, because, or it doesn't load it in separately from the other like tile map tile set, because they share the resource and it's loaded in one time. So yeah, really nice, and it lays kind of the foundation for us to implement more editors. And we also generalized the layout system so that you can, well, follow this pattern of the draw menu handle input functions that is supposed to all work for almost all editors, I guess. What else? Yeah, and we generalize sort of the serialization, these like the document stuff, like serialization, deserialization. Really nice, like pretty easy to implement, so it's not gonna be like you have to do this incredibly repetitive work of defining each serialization version of each document. It's gonna be handled automatically. So yeah, a lot of good things done. So I think with this I'm gonna put the editor development on hold and continue working on the game now. And we'll probably do, so this was like a large editor work that we did, and probably in the future it's going to be less of this. But when we put in stuff like this, like tilesheet editor, sprite sheet editor, if we need it, that is, it's gonna be more like easy to put in and require less time, because now we have the foundation that we can build up on. So yeah, that's pretty good. So what other editors are we looking at? Let's see, I have a list of like the editors that I want to have, or at least it would be nice to have. Let's see, where is that? Multiple editors, here we go. So we actually do have animations now, so we can click that in. So we have tile sheets and sprite sheets is one that's sort of planned, although it's not super necessary. I've been working with only one tile sheet so far, so it's gonna be like when you have like multiple tile sheets, then maybe it gets the spotlight for actually being implemented. Same with maybe sprite sheets. I don't really have a, well, the thing with, well, yeah, I don't really have a thing with this. Most of the stuff that I need is in animations, so it would be cool though to have some sort of metadata in the animations as well. Well, that's kind of extending the animations, but it would be cool to have metadata. Like, let's say in an attack animation, you want to put like where's the sort of hit, like damage hitbox or something like that. So you could put a square in the animation itself, so you would see where it is, and you can go into the animation and change it And yeah, that would be kind of cool. I guess you could try that sort of workflow and see if it works, instead of, you know, having to specify it, hard code it into the game, and then see if it actually fits. But yeah. So cool. So I'm gonna think of what we're gonna do next time. But yeah, thanks for everyone tuning in. So I'm gonna go now, and yeah, have a nice day, and see you later.